Okay. So you can read the first blurb. I'm basically trying to justify that this is important. Okay, trig is still used all over the place. It's one of these things that you'll see in most of the sciences. So, and the word problems can be challenging. Now the first two are really not, but then the third one you'll see what I mean with that. So let's see what we have on the first problem. So I'm looking at a flagpole. The angle of elevation. So elevate means to go up. So the angle of elevation is always an angle that's measured up from a horizontal line. So this angle is given to us as 32. And we know that you're standing 150 feet away from the flagpole, and that the line of sight, so our eyesight, is about 6 feet above the ground. Okay, that's enough information for me to find the overall height of the flagpole. When you do these problems, look at what is given, try to draw a picture if you don't have it, and then see what you have to work with. So even though I don't know what I have, h is something that I can work with, and so is 150. So how can I combine these two to write a trig function that I can work with? So what can you make out of the opposite and the adjacent side? Right. So the tangent of 32 degrees has to equal your height divided by 150. Are you okay with that part? Well, there's only one variable in there, because I can use the calculator to figure out what the tangent of 32 is. So I can solve this. So put it over 1, cross multiply. So your height is 150 times the tangent of 32. Plug that in your calculator and get an answer. Okay, and if you do that, you get 99 point, and you probably should round, not round too much here, but you know, 1 decimal is good enough. You guys okay with that?
Yes.
Is that the answer?
Plus units as minus.
Yeah, I need the units. Okay, somebody must have messed with my calculator, because that is not the right answer. Did anybody else try to put this in the calculator? The tangent of 32 times that, somebody changed my calculator to radians. So the first answer should be 93.7. Let's try with 93.7. And then you guys already noticed that you needed to add 6. So the actual flagpole will be 99.7 feet. We're okay with this one? Like, this is nice and easy, right? So if you had 10 of these, that wouldn't be a big deal. But like I said, we'll work up to a slightly more interesting problem. Okay? Alright, next problem. So a blimp.
Wait, is that all we have to?
Yeah, on that one. Like I said, the first two are nice and easy. And then we'll do one where we'll challenge it a little bit. 4,280 feet above the ground, an angle of depression. Part of this is I want you to get a little bit of vocab in here as well. So an angle of depression is measured from a horizontal line again, but depress is to push down, right? So an angle of depression is always measured down. So that's what's given to me. Horizontal again, and we have a home over there, and what we're after is actually the distance from the blimp to the house along the ground. So how can I find that? Well, there's one extra step in here. Right now I don't have any angles in this triangle other than this one, right? So if I'm looking from this angle over here, the tangent of that angle would be what? X over 4,280, right? Okay, so I would probably, to be able to do this problem, I need to figure out what this angle is. And you can figure that one out. How much is this angle? How'd you get 66? Yeah, you do 90 minus 24. That angle is 66. So it's given to us indirectly. Okay? So you could have found that angle by doing that. And now you end up with the same problem that I just had, right? Cross multiply. And so it's 4,280 times the tangent of 66. Okay? In this case, that's 9,613.0 something, so 0.03. So I'm actually going to write 0.0 here because I want to communicate to whoever is grading this that, I did round this. It just happens to round to 0. So it's 9,613. Okay. In a lot of trig problems, you can find answers multiple ways. You could have used theta over here. Like they actually marked this. Okay. If you didn't want to find this angle, could you have used the fact that these lines are given as horizontal lines both? So they're parallel. So if this is 24, this has to be 24 interior angles, right? So, and then you still end up with a tangent. It just, the tangent of 24, and then these two switch spots, and you end up solving it the same way. So a lot of these problems, there's more than one way to get to your answer. So if that's what you were thinking, that would not have been wrong. It's just not what I picked. Okay? So nice and easy problems to get into the swing of things. So now here's a much more challenging problem. So a person standing 400 feet from the base of the mountain. So initially, I'm standing right there. Yeah? 400 feet to the base of the mountain, an angle of elevation of 25 degrees. So what they gave to me here is a triangle that looks a little bit like this. With this one being 25, this is the height of the mountain. And what's the length from here to here? That's 400 plus x. Is that right? You guys see how you have to add the x to it? Because the base of the mountain is here and the height is measured perpendicular. Okay, then you move back a little bit. That means that this angle of elevation obviously has to be lowered a little bit because you're further away. So now this is 20. What do you have now in the base? You still have your height here. Okay, what's the measurement that you have now if you move back 500 feet from there? 900 plus x. Are we okay with the two triangles that you can sort of pick out of this problem? Right, so this is where it's different. Do you notice that you don't have, like, there are two variables here? So if you write the proportion that you can write based on the angle and the two measurements, you're still dealing with a tangent here, but unfortunately for you now, it's the height divided by 400 plus x on the first one. And if you do that for the second one, you end up with the height divided by 900 plus x. Yes? Well, that's two variables, so you can't really solve either one of these. But what you can do is you can solve both of these for the height. Cross multiply. So that means that the height is 400 plus x times the tangent of 25. But based on this one, the height should be what? The height should be, anybody? 900 plus x times the tangent of 20 degrees, right? So what can you do here? What can you do? Yeah, sort of substitute. They're both equal to the same height, aren't they? Doesn't that imply then that this has to be true? That 400, and I'm giving myself some room to work with, and I think you guys have plenty of room because you have the whole sheet to work with. But this has to be true, right? That one has to equal this one, correct? All right. Well, then this just becomes algebra because now how many variables do you see? One. And it is somewhat annoying, especially since I don't want you to type in what the tangent of 25 degrees is, because if you do that, you're rounding really, really early in this problem. So you're going to have to work with these expressions for a little bit. So what we end up having to do is distribute. So 400 times the tangent of 25 degrees plus x times the tangent of 25 degrees on one side. What do you got here? Let's see. 900 times the tangent of 20 degrees plus x times the tangent of 20 degrees. Do you guys see where that came from? Alright, I'm actually trying to solve for x, right? So anything with an x, I'm going to want it on the left side. So I already have x times the tangent of 25 degrees on the left. This one needs to move to the left. How do I do that? just subtract it, right? So just do minus x times the tangent of 20. That cancels it. Okay, I have 900 times the tangent of 20 degrees. Keeping in mind again, that's just a value, right? That's worth something. The calculator can figure that out. So what do I need to do with the 400 tangent 25 to make that disappear? Subtract that on the right side. So what I have on the right side now is just a bunch of stuff that's worth something. Now the calculator can figure that out. Okay, so I'm one step closer. Ultimately, I want to find out what x is, correct? Well, how do you do that? Well, x is common both here and there. So if it's common, can you factor it? Can I take the x out? And then I'm left with the tangent of 25 minus the tangent of 20. Yes? Equals. And then I just need to copy this mess. And this is why this problem is tedious and long, because you got all this stuff that you sort of need to carry along. And I have one step left to figure out what x is. What do I need to do now with this expression? Yeah, you divide by this whole mess, right? So x will be, so this is what ends up going in my calculator. I'm going to do 900 times the tangent of 20 degrees, subtract 400 times the tangent of 25 degrees, and then I'm going to hit enter. So I'm showing that by using parentheses right now in my work. Does that make sense? Then I'm going to divide that by, and I do have to use parentheses on my calculator for this, because I need to divide it by whatever tangent 25 degrees minus the tangent of 20 degrees is worth. And then this will give me what x is. So x should be what? If you do this, I don't know if anybody's gone along. So I ended up with, sorry, lost my marker again. So is that the answer that I'm looking for? What were we asked? We were asked how tall is the mountain? So is the mountain 1,378.3 feet tall? Yeah, you actually got to plug that back in. That's just x. So, and you can plug it into either one of these. So we'll just use the first one. So the answer actually comes from 400 plus this thing times the tangent of 25 degrees. So there is one step left. So we need to do that. So the final answer is 829.2 feet. And that's it. And then now you sort of hopefully understand why I said you're going to get a long time to work on your assignment. Okay?